Welcome to Brain Vision.
So part A is asking us to draw the free body diagram of the system, and this would be the free body diagram. So this would be your part A. This would have all of the forces listed out, and it would go bar by bar. So we couldn't draw the free body diagram of the diagram as a whole. However, we need to break it up into at least 3 parts in order to properly analyze it. For part B, however, they want us to find the magnitude of S sub 1, S sub 2, and S sub 3. So let's take the lower bar. So the sum of the torque of the lower bar is going to be equal to 0 because, again, all of these are in rotational equilibrium. Therefore, we can make the assumption that the sum of the net torque is going to be equal to 0. And then this is going to be equal to 6 newtons times 4 centimeters minus W sub A, the weight sub A, times 8 centimeters. And so we find that W sub A is going to be equal to 6 times 4, 24, divided by 8, 3 newtons. So that's how we would find the weight sub A. And then now we can just use the sum of forces in the y direction in order to find S sub 3. So this is going to be equal to 0. There is translational equilibrium everywhere in this system. And then this would be equal to simply S sub 3 minus weight sub A minus 6 newtons. And so S sub 3 is going to be equal to 6 newtons plus 3 newtons, which is, of course, 9 newtons. So we found S sub 3 equal to 9 newtons. And then let's go for the middle rod. So the sum of torques in the middle rod is going to be, again, 0. This would be equal to S sub 3 times 5 centimeters minus W sub B times 3 centimeters. So we should definitely find W sub B first. S sub 3 we found to be 9. So it would be 9 times 5, which is 45, and then divided by 3. So we know that W sub B is equaling 15 newtons. And then again, we just simply take the sum of forces in the y direction. This is, of course, going to be 0. And this would be equal to S sub 2 minus W sub B minus S sub 3. And so S sub 2 would be equal to 9 newtons plus 15 newtons, giving us, of course, 24 newtons. So we can label the diagram. This is going to be equal to 24 newtons. Now for the last rod, the sum of torques in the upper rod is going to equal 0. And again, this is going to be equal to S sub 2 times 2 centimeters minus W sub C times 6 centimeters. Now W sub C is going to be equal. 2 times 24 is going to be, of course, 48. 48 divided by 6 centimeters. 48 Newton centimeters divided by 6 centimeters would be equal to 8 newtons. So W sub C would be 8 newtons. And then again, the sum of forces in the y direction is going to equal 0. This is going to equal S sub 1 minus W sub C minus S sub 2. And we find that S sub 1 is going to be equal to S sub 2, which is 24 newtons, plus W sub C, 8 newtons, 24 plus 8, 32 newtons. So we can label the diagram. Okay, and then at this point for part C, they want us to find the center of gravity, and we know the center of gravity of the mobile So the center of gravity of the mobile passes through the point where S1 is located. And will lie in a vertical line. So that would be the center of gravity for part C. That is the end of the solution. Thank you for watching.